Hello students, welcome to the first video of this new playlist. So in this playlist I will be uploading solution videos of each of the question of the most recent past paper of physics unit 4 which is the October 2024 unit 4 paper. So this is the first video of this playlist. So in this video we will discuss section A of the paper. So section A basically covers the multiple choice questions. So let's get started with the multiple choice questions of this most recent past paper of physics unit 4. Okay, so at first, number 1, here the question says an electron gun produces a beam of electrons in a vacuum tube. The electrons are released from a metal filament using a current. Okay, so current has been applied. Current is flowing through the metal filament, and so electrons are getting discharged from the metal. Okay, which of the following causes electrons to be released from the filament? Okay, so just consider current is flowing through the metal filament. So definitely in order to have flow of current you should apply PD. So PD has been applied. So due to this applied PD, the metal filament will get heated up, and so it will discharge electrons. So which of the following causes electrons to get released? Okay, so the first option, it says beta decay. Definitely this is not, because this is related to radiation and radioactivity. So there's nothing in this question release of electrons. It is not related to radioactivity or radiation. Excitation, it was so close, but for excitation electron will just change its energy level. Okay, so B is not the answer. Then photoelectric effect, it is also close, but it is not the answer, because for photoelectric effect there should be presence of photons, that is light, but here there's no presence of light, so definitely C is not the answer. So the last one, it is only, the answer is D, which is thermionic emission. Why thermionic emission? Because as PD is applied to the metal plate, metal filament, it is getting heated up. There is something related to thermal energy, so it is gaining thermal energy. So it will excite the electron, and it will discharge the electrons as the electrons gain work function amount of energy. That's it. So D is the only possible answer. Fine. Okay, next is question number 2, the second MCQ. Which of the following is not the unit of a vector quantity? Which of the following is not a unit of vector quantity? Okay, so kg per meter cube. Can you figure out what's that unit? It is basically the unit for kg. Kg corresponds to mass, and meter cube, it corresponds to volume. So kg per meter cube, this is basically the quantity rho, which is density. So density, is it a vector quantity? No, it's a scalar quantity. So basically here A is the answer. Then you go for why B, C or D not the answer. Let's have a look. A meter per second squared, it corresponds to acceleration. Acceleration is a vector quantity. We know that it requires direction. Newton per coulomb. Newton per coulomb, it is what? It is electric field strength. Newton is force per coulomb, which corresponds to electric field strength. And electric field strength is basically a vector quantity, because it can be positive, it can be negative, depending on the type of the charge. So definitely C is not the answer. Then Newton second, it's the unit for what? Momentum. Fx. Sorry, Newton second, it is, yeah, unit for momentum. Newton second. Newton second, it corresponds to ft, or impulse, you can say. So impulse is a vector quantity, we know that. So definitely D is also not the answer. So the only answer is A. Okay, Next is question number 3, the third MCQ of the paper. Which row of the table shows a fundamental particle, and a non-fundamental particle? So this is basically from chapter number 7, particle physics. Okay, so at first, option A, it says alpha particle, it says fundamental, non-fundamental is neutron. Okay, so alpha particle, it's not a fundamental particle, definitely not, because alpha particle can be divided. If you break alpha particle, you will get what? A helium nucleus is being divided, so you will get two nucleons in its two protons basically. So alpha particle is not fundamental. Okay, then it says leptons are fundamental particles. Non-fundamental, it says meson. Yes, meson is a quark. It consists of an up quark. It consists of a quark and an anti-quark, right? So if you divide a meson, you will get two quarks. So meson is non-fundamental and lepton is fundamental. Okay, so B is basically the answer. So what about the other options? Already I said part A, alpha particle is not fundamental. Neutron is correct. It's non-fundamental, but alpha, it's not acceptable. Okay, then proton is not fundamental because proton is a baryon and it consists of what? 3 quarks. Okay, so this is not fundamental, so C can't be the answer. So next is fundamental quark. Option D, it says quark is fundamental particle. Quark is a fundamental particle. A non-fundamental particle, it says muon is a lepton, so muon is a fundamental particle, but muon is under the column non-fundamental, so D is not the answer. So only possible case is option B, which is fundamental particles are lepton and non-fundamental is meson. Fine. Okay, next is question number 4, the fourth MCQ of the paper. So it says the isotope 222 radon, it has a mass number 222 and a proton number 86, decays by emitting an alpha particle. Okay, which of the following shows the nucleons in the isotope produced by this decay? Okay, so at first consider the decay. So it has mass number 222, it's radon with proton number 86, it emits alpha particle. So alpha particle has mass number 4, proton number 2. Since it is basically the helium nucleus has 2 protons in its, helium nucleus has 2 protons. Okay, so the resultant element, it would be 218. It will have mass number 118 and proton number 84. So the question, the options you can see here, it is asking about neutron number and proton number. Okay, so we got the mass number. So mass number is 218. From 218, if you subtract 84, the proton number, you will get the number of neutrons. So number of neutrons is 134. 134, the only option, it is A. So A will be the answer. 134 neutrons and 84 protons. The rest are 136, definitely not possible. 218, it's not. 220, definitely it's not. Only the answer is A. Fine. Okay, next is question number 5, the fifth multiple choice question of the paper. Okay, here the question says an electron is traveling horizontally at velocity v through a uniform magnetic field of magnetic flux density B. Okay, the magnetic field is at an angle of 24 degrees to the vertical as shown. Okay, so we can see that the magnetic field B, the magnetic field density, it is at an angle of 24 degrees to the vertical. Okay, so there is a force F acting on the electron due to the magnetic field. The force F is acting into the page. Okay, the direction of force is into the page. Which row of the table gives the magnitude and direction of V? Okay, so there are four options given. The four options shows magnitude of the velocity and direction of velocity. Okay, so at first, before going to the, we have seen the options, fine. So now consider the pattern, the scenario of this electron, the motion of this electron. Look, so to understand the direction, at first let's consider the direction so that we can eliminate some of the options. So to consider the direction, we have to use the Fleming's left hand rule. Okay, so for Fleming's left hand rule, the question says the force F is acting into the page. That means the thumb finger should be into the page. Okay, and then the direction of magnetic flux density, which is B, it is represented by the middle finger. It is represented by the middle finger, so it will be what? Downward. So sorry, the magnetic flux density is represented by the index finger, so it will be along B. So thumb finger into the page, index finger towards B, towards the direction of B. Basically it's towards this direction. Okay, so direct your index finger towards this way and then open your middle finger. So if you do so, you will see that the middle finger, it is directing the current towards this way. This is the direction for current. Okay, so thumb finger into the page, into the screen, index finger towards the direction of magnetic flux density, that is B, towards this way. If you open the middle finger, you will see it is showing X to Y. This is the direction of current. So the charge of the electron, it is negative. So since electron is negatively charged, so the direction of current is opposite to the direction of movement of electron. So that means electron is moving this way, Y to X. So which of the options are showing Y to X? Either this one or that one. Okay, now consider the magnitude. Okay, for considering the magnitude, we will have to use this formula for magnetic force. This is F equals to BQV. So this formula is when the magnetic field is perpendicular to the current, but here the magnetic field is not perpendicular to the current. So in that case, we need to figure out the perpendicular component of the magnetic flux density. Okay, so consider this triangle. This is the horizontal component parallel to the direction of current. This is the perpendicular component. Okay, so we need to find out this perpendicular component, and this is the resultant. So this is direction of B. This angle is 24 degree. So this angle would be what? 66 degree, and this is 90 degree. Okay, so between B or D, they are considering sine. Okay, so we will use sine 66 degree to get the vertical component. Sine 66 degree equals to, this is B vertical, the vertical component of magnetic flux density, over hypotenuse is B. So B vert, the perpendicular component of magnetic flux density, it is B sine 66 degree. Okay, so if you make V the subject, V would be F over the perpendicular component, we got B sine 66 degree times Q times Q. That's it. So which one is similar to the one we got for V? This is basically this one, D. So D is the correct answer in this case. So E is basically the charge of electron. So that's the answer for MCQ number 5. Fine. Okay, next is question number 6, MCQ number 6. So here the question says an electron has a kinetic energy of 3.5 times 10 inverse 28 joule. Which of the following gives the momentum of the electron in kg/m/s. Okay, so momentum of the electron. So before we get into the options, let's consider the relations. Let's relate kinetic energy with momentum. So we have learned this relationship from chapter number 5, that is further mechanics, that kinetic energy and momentum can be related by this formula, E equals to p square over twice of m. So they are asking for the momentum, so make p the subject, so that would be 2me. So square root of 2me. M is the mass of the electron. Okay, so either C or D would be the answer, but in option C they are saying they have written the charge of electron instead of its mass. So C is not the answer. Only answer is what? D. So for question number 6, D is the answer. Fine. Okay, next is question number 7, the 7th MCQ of the paper. So here it says a moving trolley collides with a stationary trolley and they move off together. Okay, frictional forces are negligible and the collision is inelastic. So frictional forces are negligible and the collision is inelastic. Inelastic means what? The kinetic energy is not conserved. Okay, and frictional forces are negligible, it means what? The system is a closed system. That means there are no resultant force acting out from outside. Okay, so which row of the table shows what happens to the total momentum and to the total kinetic energy in the collision? So since the system is closed, so definitely the total momentum of the system will be conserved, right? So either A or B would be the answer, but the question says the collision is inelastic. So for inelastic collision, kinetic energy will never get conserved, right? So the only possible answer in this case, it is B. B is the answer. Total momentum conserved, total kinetic energy, it's not conserved. Fine. Okay, next is question number MCQ number 8. Cyclotrons accelerate charged particles to high speeds. Cyclotrons use electric fields and magnetic fields. So cyclotrons, it's a type of what? Particle accelerator that we have learned in chapter number 7 of A2 physics. Okay, so which of the following statements is not true, not correct? Okay, so the first option, it says the magnetic field is at right angles to the velocity of the particles. We know that in cyclotron, the direction of motion of particles, it is at right angle to the direction of magnetic field. Magnetic field is provided perpendicular to the D's. Okay, let me show you the cyclotron. This is a cyclotron. So there is electric field between them and magnetic field is basically perpendicular into the screen. Okay, so A is correct. So the question has asked not correct. Okay, let's see the next option. The magnetic fields in the D's keep the particles following circular path. This is also correct because for cyclotron we know that the equation that it follows, it is BQV equals to mv square over 4, mv square over 2, right? mv square over r, sorry. So it is following circular path. So centripetal force is the magnetic force provided by the magnetic field. Okay, so B is correct. B is correct for cyclotron. So B is not the answer. The next option is C. It says the particles are accelerated by electric fields between the D's. Okay, so electric fields are acting between the D's. Correct. It is true for cyclotron because this D is connected to one end of the battery or one end of the power supply, and this D is connected to another end of the power supply. One is connected to positive end, another one is connected to negative end. So as they are connected, electric field will form between them, right? between the Ds. Electric field are forming between the Ds. So this is true for cyclotron. So C is not the answer. So the only possible answer is D in this case. It says the particles are accelerated by electric fields inside the Ds. Is it inside the Ds? No. The Ds, the electric field is between the Ds. If it say inside means if you consider this is a D, electric field is within this region. No, it's not true for cyclotron, right? So D is the answer. Fine. Okay, next is MCQ number 9. So it says scientists in the early 20th century detected beams of alpha particles at thin metal foils. Okay, which of the following conclusions were they able to make from their observations? So basically this question is related to the Rutherford's alpha particle scattering experiment that has been discussed in chapter number 7, that is particle physics of A2 syllabus. Okay, so which conclusion were scientist Rutherford could make from the observation of the experiment? Let's have a look on the options. Option A, it says all of the charge of the atom is concentrated in a small volume in the atom. All of the charge. It means that both positive, negative, neutral, all charges are concentrated in a small volume. No, it was not observed, right? So A is not possible. B, option B, it says most of the mass of the atom is concentrated in a small volume in the atom. Yes, it is one of the possible. It is possible. Most of the mass. It was observed from the Rutherford's alpha particle scattering experiment that there is a region, there is a center part which is massive and it is very dense. So to be massive and dense, definitely all the mass should be concentrated there at the center part, right? So B is correct in this case. Okay, let's see the next, why the next two options not correct. The electrons orbit the center of the atom in specific energy levels. No, it was not observed from the experiment. Then D, there is a nucleus made of protons and neutrons. No, from the Rutherford's alpha scattering experiment, it was not concluded that nucleus is made of protons and neutrons. So D is not the answer. So the only possible correct answer is B. So B is the answer for MCQ number 9. Okay, next is MCQ number 10, the last MCQ of the paper. So here it says a proton and an antiproton travel in opposite directions towards each other. Each particle has energy of 450 giga-electron-volt. Okay, well each particle has energy of 450 giga-electron-volt. When the particles collide, they annihilate and creates a particle-antiparticle pair. Which of the following expressions gives the maximum mass in kg of the antiparticle produced? Okay, mass of the antiparticle produced. Okay, before we see them, the options, consider in annihilation how the energy is converted to mass. It can be related by the equation E equals to mc squared. Okay, so from there we need to figure out the mass. So make mass the subject, E over c squared. Okay, so here the energy is given. This is the energy for each particle, single particle. So in place of E, it should be 450 giga-electron-volt. So 450 giga-electron-volt, it is 450 times 10 to the power 9 times electron-volt. It is the charge of an electron, 1.6 times 10 inverse 19 coulomb over c squared. C squared is the speed of light in vacuum whole squared. So which of the options is similar to this one? No, this one is not, because it says 2 and also 10 to the power 6. No, 10 to the power 6. No, this is not possible. C says 450 times 10 to the power 9 giga-electron-volt. Okay, over, okay, c squared. C is the answer. C is the correct answer. D is also not. It says 2, which is it is making it doubled. No, D is not the answer. So only possible answer for the last MCQ of this paper, it is C. Fine.